My dear students, last class we discussed a radial wave function, and I said you in the beginning that wave functions have two part, radial part and angular part, and we already discussed radial wave function, how radial wave function is plotted with respect to radius. Now we will go to details of angular wave function. Angular wave function, it gives in which direction, in which direction electron density electron density electron density is present. This is one of the ideas angular wave function tells you, in which direction electron density is present. It also tells about this angular wave function. It also tells tells about the probability the probability the probability that probability of an electron at two angles theta and phi from the axis. Okay, for example, suppose two angle, we take only one angle here because two variables are here, theta and phi. Therefore it is quite difficult for us to explain. Suppose you have imagine you have a situation like, imagine you have a situation of in which angles your the probability of electron density. Okay, this is our theta, suppose theta. Similarly, it is two-dimensional. When you go to the three-dimensional, you will have one more angle in three-dimensional also. Yes, this angular wave function is a normalized wave function. We have already discussed what is a normalized function, how to calculate a normalized function. Okay, it is represented angular part of wave function represented as psi theta phi. Okay, psi theta phi. Okay, where it's square, that is psi square theta phi is the probability density in two angles. This angular wave function psi theta phi represents or depends only on two quantum numbers L and M. Okay, and independent of principal quantum number n. Therefore, in short, angular wave function tells you the shape of the orbitals. From where we are going to the shape of the orbital. Suppose in the oneness orbital, okay, you have two axes, x, y, z axis. This is y axis. Suppose it's a y axis, z axis. Okay, this is our probability graphs, the phi graphs, and you mark a boundaries of 90% probability density at different angles and join them, you will get a spherical shapes. You will get a spherical shape. Is it okay? Similarly, for pz orbitals, suppose pz orbitals, you mark, this is your shape of the orbital. This is our shape of the pz orbitals. Okay, how do you get it? This is obtained by plotting. Probability density in different angles. Probability density in different angles around the nucleus, and we will mark 90% above probability density contours, boundaries. Those boundaries are joined, you will get a dumbbell shapes. Therefore, angular wave function gives you the shape of the orbitals. Therefore, from where we lead to the shape of the orbitals. Okay, fine. Our next topic is shapes of orbitals. Please make the note of shapes of orbitals, and s orbital, p orbital, d and f orbital shape. Then quantum numbers. Quantum numbers. Make a short note on these two. Okay, I hope the chapter is finished. Thank you for watching.